Hello everybody, Bradley Sward here, and this is my Day 6 Part 2 solution to the Guard Gallivant problem for Advent of Code 2024. I'm doing this almost as always in Python, and for Part 2 of this problem, what you're trying to do is you got your guy walking around guarding some perimeter and some space, and we're trying to figure out which of the dotted squares can I put down an obstacle so that the patrol goes in an infinite loop and we can go do whatever we want everywhere else, I suppose, right? Because that's what we do. We thieve on elves and do all sorts of crazy stuff. So this changed my code a bit, but you can see, and it's slow as heck. I know how I can improve it. I see the places I can improve it. It's going to take a while for this thing to go through, but it will get the correct answer when it gets through. I'm just running it a second time. So what am I doing here? What am I doing? I still have the thing where I tell them, get the element from my list of lists. I still open up the file and I unpack the thing. I get the starting X and starting Y for our little man that's patrolling so that every time we start on each one of them, we can just start from there. We know which our directions are, cardinal directions, so as it turns here, this is going up, and then this will turn to the right, and then this will go down, and this will go to the left, and then now it'll come back around, so it's 90-degree movements every time. And then here's the fun of the code here, right? For every X and every Y in the game, or in 130 by 130 square, I guess I could move. I'm not going to do it. I could move the direction in here anyway. Say like if it's a dot, well then let's make it an obstacle. We'll put it back so that we don't have to rewrite anything. But for now, we'll say, there's an obstacle there. Let's put our patroller at the starting position with a direction going up, and then basically the places he's been is this place that he's in right now, and then it's basically saying there's two ways out of this loop. If we go off the screen or off the game world, that's one way out, and then that way we didn't find that it's an infinite loop if the character can get out of the world. And then otherwise, we just keep on trying to say, we just keep trying to see if we can find an infinite loop. And we do that by creating a set of points with their directions. Because if it's not the same to get to a certain point if you're going in a different direction, because the bounds could be different, right? And the bounds could take you in a different direction than anything else could. So we have to make sure that we're keeping track of the start position and the direction. And if we see that twice, we know we're in a loop. And I used a set instead of a vector to speed things up. This is still slow as heck, as things go, but I still see how I can improve it if it wasn't 2 in the morning here and I'm done and I need to get some sleep and go on to other things. Now I see what I can do. But anyway, so this will print out everything of the answers as it goes through, using the same principles as step 1, just continuing on. But going, if I get off, then I haven't found anything. But if I find the same number inside of my list, then I know I've reached an infinite loop. And if I know I've reached that infinite loop, I can tell you it's a success at this point. And then say that's movements, and then this is basically done here at the at the at the collision point. So my thought of improving things would basically, instead of just continuing to put numbers and numbers and numbers in, only put in the values that are at the collision points. I was starting to do that, and then I just wanted to make sure that I got this video in, but I believe that'll speed things up super greatly if I'm not adding thousands upon thousands of points that don't matter to the algorithm here. But anyway, so I will let this run for as long as it needs to. I'm just going to shut my mouth for a couple of minutes and do other things while this is finishing up. But if you have any questions, concerns, anything, I'd love to hear about it. I'd like to hear about your solutions too. If anyone never gets this far in the video, who the heck knows? I'm having fun. Hope you're having fun too. Thanks for watching. Have a great day. Take care.